Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, we are going to understand the internal architecture of Cortex M3 processor, nothing but ARM Cortex M3 processor. Before starting the video, if you are a new viewer to my channel, subscribe to my channel and gain the knowledge on embedded system. Let us start the video ARM Cortex M3 architectural overview. So before starting the video, first of all, you should understand why we have to learn ARM Cortex M3 processor. If you consider our embedded system, especially the industry standard embedded system application, most of the microcontrollers are coming with ARM Cortex processor inside, especially this ARM Cortex M3 and M4. So if you know the internal architecture of ARM Cortex M3 processor, it will be very easier to understand the microcontroller in detail in upcoming classes. So let us start the video here. ARM Cortex M3 processor. So this is the architectural block diagram of your ARM Cortex M3 processor. So what is there inside the ARM Cortex M3? Basically, this ARM Cortex M3 is a 32-bit processor. This is first of all, you should understand. It's a 32-bit processor and it is having ARM core inside, nothing but a 32-bit processor or a 32-bit core inside. We have a memory protection unit, we have serial viewer, we have NVIC. So this time we are having NVIC, that stands for Nested Vector Interrupt Controller. Then we have a specialized wake up controller, that is called as WIC, stands for Wake Up Interrupt Control. And then we have here memory peripheral interfacing. So this is a simplified architectural overview of Cortex M3. Let us dive in deep with ARM Cortex M3 architecture. So I told you already, ARM Cortex M3 processor is basically a 32-bit processor core which is designed to design a low-cost microcontroller. So it is designed to manufacture low-cost, high-performance, real-time microcontroller applications. So this is one of the fundamental things you should know. ARM Cortex is basically a 32-bit processor which is used in most of the microcontrollers. And it uses ARM version 7. So in ARM we have different versions, version 4, version 5, version 6, like that. So this ARM Cortex M3 will fall under version 7 M architecture. So M here, what is the M stands for? M stands for microcontroller architecture. ARM Cortex M here stands for microcontroller architecture. So ARM version 7 M architecture, your Cortex M3 processor follows. Since it is a 32-bit microprocessor, it will have 32-bit data path as usual. So 32-bit data you can transmit at a time, 32-bit address you can pass at a time, and most of the registers are 32-bit, and we will also get 32-bit memory interfacings as usual as a typical ARM processor design. Operating speed, the 50 megahertz to up to 300 megahertz it can operate with operating speed, and operating voltage which starts from 1.8 to 3.3 volts operating voltage. This ARM Cortex M3 will follow the Harvard architecture. That means we will have separate buses for addressing nothing but data transmission and instruction transmission. That is called as a Harvard architecture. And beauty of ARM Cortex M3 is thumb 2 instructions. We know thumb, but ARM Cortex M3 processor will use ARM thumb 2 instruction, and which is going to produce a very high density, delivering high code density, and it leads to increase the performance of your ARM processor. So this is one of the big advantage of thumb 2 under Cortex M3 processor. It uses a 3-stage pipelining. You know that already what is a pipelining. So a parallel execution of fetch, decode, and execution. So it uses 3-stage pipelining, 3 executions in a synchronous way. And it uses both little endian, and it will support for both little endian and big endian. Okay, these are all simplified points of your ARM Cortex M3. Let us go with some more features. ARM Cortex M3 processor will use something called as NVIC. So what is this NVIC? In the regular ARM processors, they use a VIC, that stands for Vector Interrupt Controller. But here, ARM Cortex M3 processor will use NVIC. Okay, So NVIC stands for Nested Vector Interrupt Controller. You can create an interrupt within the interrupt, and whichever is having a highest priority, that interrupt will be served first. Even the low priority interrupt, if it is serving, the higher priority interrupts come into picture, then higher priority interrupt will be served, lower priority interrupt will be kept under suspension. So that is called as NVIC, and this NVIC is used to configure the interrupts, and also it is used to assign the priority levels. So that is the use of NVIC. Here you can see this is called NVIC block. And also this NVIC, what is a good thing about NVIC is you can go up to 240 interrupts. That is a very beauty of your NVIC. Up to 240 interrupts you can configure with the help of NVIC. Okay. And then we have a MAC here. The MAC stands for multiply and accumulator. With the help of MAC, but this MAC is not visible on this on the block diagram, in the block diagram, but this MAC unit will be available in the ARM core. Okay, so this MAC, it is also called as hardware division or hardware multiplication. So this MAC unit, you know that already what is a MAC. MAC stands for multiply and accumulate. With the help of MAC unit, we are able to multiply two 32-bit registers to two 32-bit digits or two 32-bit numbers, and also it is possible to divide two 32-bit integers, and this will help in the digital signal processing. So in the DSP processing, we'll be using convolution, Fourier transformations, many multiplications. Many times we will be using multiplications and divisions. In that scenario, this MAC unit will be very helpful. That is why it is called as hardware division, which is going to help, very beneficial to the signal processing applications. Okay, and then we have CMSIS here. In our Cortex M3 processor will also support something called as CMSIS. CMSIS. The CMSIS stands for Common Microcontroller Software Interface Standard. The full form of CMSIS is Common Microcontroller Software Interface Standard. So what is the meaning of this? This is a standardization of your coding mechanism. With the help of CMSIS concept, most of the functions related to Cortex M3 processor we can reuse in a different microcontrollers. That is what here he's telling. The core is supported with a CMSIS, which will provide a standard way of accessing processor features and promotes code reusability across the different microcontrollers. If you develop one set of code in one microcontroller, the same code you can use in a different microcontroller of a different manufacturer with the help of CMSIS concept. This is also one of the good advantage of our Cortex M3 processor. Okay, so these are all the overview, and let us dive into some more points here. Memory protection unit. So we know that MPU stands for memory protection unit. In short form, we will call MPU, memory protection unit. Name itself says that it is going to protect our memory. So if you observe our memory organization, we will have a code, we will have a RAM, we will have SRAM. So we should not violate our memory, which is defined from the processor. So that will be taken care by memory protection unit. So memory protection unit is used to manage protecting the memory regions which are defined for different applications. Debug and trace capability. Here you can see we have something called as data access point, data watch point, and serial wire viewer. So these things, especially the serial wire viewer, which will help in a single wire, we can able to check the output in the real-time environment. So this will provide a single wire interface which is used to access a real-time registers in a real-time environment, in a debug environment. Okay, so that is one of the big advantage of a serial debugger, or you can say serial debugger. In a simple word, it is a serial debugger which is used to debug your code step by step. This serial debugger. And then, so I already told this processor is used for a low power operation. So low power means one thing is the operating voltage from 1.8 to 3.3 volt, and second important thing is the ARM Cortex M3 processor will support sleep mode and deep sleep mode. So that means whenever there is no execution and whenever there is no instruction to execute, or whenever there is no program to execute, processor will enter into sleep mode and deep sleep mode. So which is going to save the lots of power for our embedded system applications wherever the energy is very crucial. So this is one of the big advantage, low power mode, or you can also say that sleep mode or deep sleep mode. And in order to wake up the processor, we have a separate block, something called as WIC. Here you can see. So this WIC stands for wake up interrupt control. So this is a separate block or separate interrupt block which is defined in our Cortex M3 processor in order to wake up the processor when processor is in sleep mode or in the deep sleep mode. If processor is entered into sleep mode, how do you wake up that? So we have interrupt mechanism that is called as wake up interrupt control. So with the help of WIC, we will be able to wake up the processor. And coming to the registers, so we have lots of registers. Here you can see we have totally 16 general purpose registers, and then we have some special register here. So we have R0 to R15 general purpose registers, and we have PSR, that stands for status register, program status register. Then we have pre-mask, then base priority, and then control registers. So all these are all special register. I'll be explaining in detail in the next upcoming videos. So R0 to R15, these are all called general purpose registers. Then we have operating modes, compared to our ARM operating modes. So here also we have different operating modes, but broadly it is divided into only two operating modes. One is a thread mode and one is privileged mode. One is a thread mode and one is ARM Cortex processor operates in two modes. One is thread mode and one is called privileged handler mode, or you can say main programmer mode, and one more is handler mode. So mainly it is going to operate in two modes. One is a thread mode and one is a handler mode. So handler means, so whenever there is an interrupt, the processor will enter into handler mode, or it's also called as privileged handler mode. Or whenever there is an exception, processor will enter into the exceptional mode, that is called as privileged handler mode. Okay, so whenever the processor is executing your regular normal instruction, then processor lies either in a user mode, or you can say user thread mode, or it is also one more mode is called privileged thread mode. We have two different modes are there. One is so we have user thread mode and we have privileged. So what all these I'll be explaining in the next upcoming videos. As of now, just keep it in mind. We're having only two operating modes. One is called thread mode and one is called privileged handler mode, and thread mode is divided into two. One is a user thread mode and one more is privileged thread mode. So coming to the registers part, as I told you already, so we have totally 16 general purpose registers. Currently what you are seeing on the screen, R0 to R15, there are totally 16 32-bit registers available. Plus there are some 4 special registers are available. One is a status register, one is a mask register, one is a fault mask, base pre, and control. So all these things I'll be explaining in upcoming videos, but in today's video I'll be concentrating only on general purpose registers. So there are totally 16 general purpose registers available. So first classification you can see like this, R0 to R12. So out of 16 general purpose registers, 13 general purpose are accessible for the programmer. R0 to R12 general purpose registers you can use for programming. Okay, all are 32-bit registers, and at the same time, whenever you're using a thumb mode, you know that already what is a thumb mode. Whenever you're using a thumb mode, lower 7 registers, nothing but R0 to R7 are accessible for the programmer. Only lower 8 registers are accessible whenever you're working in a 16-bit operating mode. Then coming to the R13, up to R12 it is general purpose, and we have R13, nothing but stack pointer. Here you can see. So beauty of ARM Cortex M3 processor is we have two stack pointers. Stack pointer R13 is also called a stack pointer. Cortex M3 processor will contain two stack pointers. One is called as main stack pointer and one more is called as process stack pointer. So what is this main stack pointer will do? The main stack pointer is responsible for executing privileged mode. Try to understand the sentence here. As I told you already, we have two operating modes. One is called privileged, one is called handler mode, and one is called thread mode. And one more is, again, it is subdivided into two things. One is handler mode, one is a user thread mode, and one is privileged thread mode, like that. So based on the type of application, the main stack pointer, MSP we will call, here you can see MSP and PSP they have given. So main stack pointer, MSP, the default stack pointer, it is used by the operating system or a kernel and in exceptional handler and in privileged software. So whenever you're operating in an exceptional handling mode or whenever you're operating in a privileged mode, your main stack pointer will be used. What is this privileged mode? I'll be explaining later. Okay. So what do you mean by MSP? MSP is a default stack pointer which is used in exceptional handlers and in a privileged software. And what about process stack pointer? We have one more stack pointer, PSP. Here you can see the PSP stands for process stack pointer or a processor stack pointer, which is used by the unprivileged user applications. Okay, unprivileged, nothing but it's a normal user mode. Whenever you're using in a normal user mode, this PSP is used or processor stack pointer is used. In detail, we'll see later. Okay, then the R14, you know that already. What is R14? R14 stands for link register. So link register. So what is the use of link register? The link register is used whenever there is a subroutine is called, the return address will be stored in the R14. Whenever the subroutine or a function is called, the return address will be stored in R14 register. Okay, so that is the beauty. And lastly, R15. R15 is your program counter. So that means you know that what is a program counter. Program counter is used to store the address of next instruction to be executed. Program counter, it's also called as R15. R15 or program counter is used to store the address of the instruction to be executed in the next step. Okay, so this is a simplified explanation of ARM Cortex M3 processor with the general purpose registers. So with this, I just want to end my video here. In the next upcoming video, I'll come up with one more topic of ARM Cortex M3. So subscribe to my channel and gain the knowledge on embedded system.